No. Okay, today we're going to do quiz review for your area volume unit quiz, which will be on Wednesday. Tomorrow, I'm going to be checking the remaining homework or from your packet, the AP practice problems for unit 8 at the end of your packet, so 1 through 7. I'll then remind you this afternoon. I'll also I have the key on the website as well. Okay. Okay, just want to give you a quick overview of the remaining weeks of this semester. I'll give you this calendar in the packet for you. I have for you tomorrow. So we're going to go through a series of FRQ review. There's really only 2 FRQs that you haven't quite seen yet, which are the rate in, rate out, and then also table of values derivative graph, which you've kind of seen, but you haven't quite seen it all together in this particular format. So we will do quiz review today, but then we'll do rate in, rate out tomorrow. Your quiz will be on Wednesday. You will get to use your calculator on Wednesday. And then Thursday, Friday, and Monday, we're going to just run through that particular type of FRQ that you're going to see, which is, yeah, just basically a derivative graph. But the things I'm going to ask you to do are very specific. So you know how to do it. We just have to kind of practice through that. So we'll have a quiz over this particular type of FRQ on Tuesday, and all the review that's leading up to it. I'm going to let these homework grades be a part of your quiz grade as well. So it'll be a nice way to balance out that grade. So as long as you're turning in your homework, you get full credit for that homework. And I haven't figured out the percentage yet, but it's going to be a significant percentage of your quiz grade. So that'll balance out your quiz grade. Okay, and then the next thing is Wednesday, Thursday, Friday. We'll also review through the other set of FRQ, which is just the rate in, rate out, which we're going to go over tomorrow. And then differential equations, Riemann sums. You've already seen that already, so I'm just going to give you a different variation of that problem for the FRQ. And these 3 homework grades will also go into this quiz grade as well. So so you have 2 quiz grades coming up, but everyone should do well on them. Because it'll be just like the review I gave you and the homework grade that you're doing them. The homework grade that's associated with it will also go into your quiz grade as well. And then the remaining days are just recovery days. I'm really just going to spend Tuesday just trying to finish all the grading for my AB and my BC students and identifying the grades that are below 75 so that you have a chance to recover them if you want to that Wednesday, Thursday, Friday. And there'll be half days. They say that they want first, second, and third period to be doing makeups on Wednesday, 4th, 5th, and 6th on Thursday, and then 7th an appointment on Friday. But really, you can come in anytime that your schedule allows, and you can make up any quizzes or tests that you want to make up. Just give me a heads up ahead of time. All right. Any questions with our remaining? Yes.
So we have
No more test grades, just quiz grades. Okay. just quiz grids. Okay. All right, so do we all have our review packet? We all should have a review packet as well as the key associated with it. If we don't have it, raise your hand and I'll get that for you. Yes. Yeah. Everyone have the key and the blank worksheet?
Yes.
Okay, so let's start with number one. I would like for us to work this in both ways so that on the quiz, you can do whichever way you like, but for now, I'd like for us to do both ways. So if you want to do this from a top minus bottom perspective, what do we have to make sure we take care of? Intersection, right? Because how many integrals do we need for this problem?
Two.
We need two, right? There's a different top function for the two regions. So we need to do top minus bottom for 2 to wherever that decimal value is. So try top minus bottom, but I also want you to try this from a right minus left perspective. If you do right minus left, it's nicer in the sense that there's only one integral that's needed, but you have to spend time rewriting the two equations, and then the balance also has to be adjusted from y value to y value. Try the top minus bottom first, and then you can try the right minus left. Oh, and then I want to point out page 14, these are the formulas that you need to memorize. I mean, I think you already kind of know them already. Really, you're just this method, washer method, area, and then also the area formula for cross section. I know, again, these feel like a lot of formulas, but really every formula is base squared. You just have to figure out what coefficient goes with which shape, right? So 1/2 is for right triangle. Isosceles right triangle with hypotenuse is 1/4. Equilateral triangle is √4, and semicircle is pi/8.
The intersection, I can just use the calculator, right?
That's right. Yeah. So really for the quiz, all the calculus and all the algebra can also just be done in the calculator. I'm really just looking for the setup. If you can do the setup, then the calculator will do all the work for you.
You don't have a visual representation.
Yeah, I'm going to draw all the graphs for you.
Okay.
Yeah. But you still want to make sure you can use your calculator to find intersections that you need to find. And really, it just wants you guys to go through the first 2 pages. And if we're done with that, then we can go to the last 2 pages, because that's another review page that's similar to your quiz format. Let me know if you have any trouble with your calculator or with keystrokes in your calculator or setup. I want you to feel comfortable by the end of class today, so you know what to do to prepare for your quiz.
Wait, we're doing top to bottom or right to left? Okay. Yeah, so how do I find the Y here?
Oh, you have to graph both curves
Okay,
and then look for the intersection.
Right.
Yeah, for the white rules.
yeah, I got it. I'm just thinking, we gotta do it manually.
Yeah, it's easier to do it graphically than algebraically. Once you get top minus bottom down, then also do it for right minus left. I just want to see you to want you to feel comfortable going back and forth between the two forms. Oh, right. So I'll put it on the board. So the first argument will be the expression, the second will be x, third will be a lower bound, and fourth will be. It's weird. And so you should get the same answer, whether you do top minus bottom or right minus left, so I want you to feel comfortable with both methods. You're good with one, go to two. Okay, so our goal for today is we can get through the first 4 pages. I think we're in good shape. And then for your additional practice, getting ready for the quiz, you can also do pages 11 through 13. That's also really good. Give you a really good feel for what your quiz will look like. So, but today if we get through pages 1 through 4, we'll be good.
There's a reason why it's only like a.
Because there's no rotation going on. So all these are built on top of the base, so it's only circle related when they're rotating like these, or if we're like a semicircle.
Okay.
Move on to page 3 and 4, and here with 1 and 2.
That means that you're able to more things. It's formula fees. It's right, like such as right, and that's what we got the trades. For like, this is my. I just was actually from both of them. Yeah. Oh, sorry. So you have a question.
Yeah.
So hypothetically, is now wanting to get that on the right wing, like, just curious.
I would have solved for X. I'm gonna take raise both sides, base E, and then solve the rest of it. And then you're gonna use that Y value, or that value is right here. Oh, wait,
We haven't keep it on, no, like.
no, you're rotating around around the Y axis.
If you already just found the area.
Oh, just the area.
Okay.
Right. So that's what I'm thinking. Sorry, 1.0.
That'll be right minus one.
I'll be right myself.
Yeah, wouldn't it? Yeah, I just wanted to see how it looks visually.
Makes sense.
Because we're rotating around X. So the X is right up against the shape. There's no gap. There's just one continuous function, but there's like any one thing, it's just one right. So once it rotates around, there's no hole, it's just one solid object. It's like in this case, the whole thing is that it's not gap. There's no gap. If there's no gap, then there's no resistance. Like even if this was up against that, up against this point, it's still going to wash your method. It's still a gap there. So the only time that this may wash this method, if a flat surface up against the dotted line, that's it. Okay, let's continue working for 5 more minutes.
Sorry, this isn't drawn to scale, right? Because this is one, then two.
Yeah, that's strong. Let's get up.
Just to help you.